Hi, I'm Dawn Taffel from FRM, and we are excited to present to you today lighting control scenarios, applying different control strategies to meet your client's needs. And we have three guest speakers that are experts in the control field. We have David Fuse, Caitlin Ryder, and Sam Worst. David has over 25 years experience as a veteran of the lighting industry, specifically focused on specification of commercial lighting and controls and motorized window treatment systems. Upon graduating from Syracuse University with a BA in economics and German language literature, David spent 10 years working for Lutron Electronics and in specification sales on commercial project management capacity and LED and Lutron sales office in Berlin, Germany. For the past 17 years, David has worked as a manufacturer's representative serving North Carolina and South Carolina. David enjoys working closely with design and MEP firms, supporting them in their business with the development of lighting control, window treatment lighting, and specification solutions for their clients. David and his wife, Renata, have 3 sons and live in Charlotte, North Carolina. Caitlin Ryder holds a BFA in theatrical lighting design and production from UNC Greensboro. With over a decade of dedicated experience, she currently serves as a lighting control specialist for SESCO. Her commitment to excellence is underscored by her CLCP and PMP certifications. As a dynamic speaker, Caitlin illuminates the intersections of creativity and proficiency in the ever-evolving landscape of lighting design. Sam Worst is a specification sales agent for KB Stevens here in Wake Forest, a manufacturer's rep agency in Eastern North Carolina with over 8 years of experience. He's assisted architects and engineers with lighting specifications for products including offices, healthcare, education. He also leads pre-construction meetings with electrical contractors for review lighting controls, helping them to have smooth installations and the commissioning process. Sam is a proud graduate from NC State with a degree in the industrial and systems engineering. With that, we'll let David Fuse begin.
Thank you, Dawn. Wonderful. Okay. Well, let me just start again by thanking everybody. I really appreciate the opportunity to speak with you today. I think it's safe for me to just kind of reiterate, not just for myself, but also for the other speakers that, just in the interest of time, what we're going to present today is pretty high level on all 3 topics. So if there's anything that you see that you'd like some more information about, or you'd like some additional detail, I would say certainly feel free to reach out for any of us, and we'll be happy to either connect the dots or get you with the right person or meet with you personally and just help out any way we can. So again, thank you very much. We're going to talk a little bit today about networked lighting controls. Kind of a very broad topic that may mean quite a different number of things to different folks in different projects. So, typically when people talk about networked lighting control systems, what my experience is, they're thinking about much larger applications, much more sophisticated projects where, of course, we're controlling the lighting with that, but also we may need to control other sources, maybe window treatments, maybe we need to tie in to the building management system, maybe we have audio video integration, so on and so forth. And the reality is, while that can certainly be the case, oftentimes the category has broadened to the extent where not every project needs to be a very large application. In fact, we do quite a few smaller projects with network lighting control solutions, simply because sometimes you may not even realize you have a processor that is built already into some type of a network controller or room controller or a load controller. So this slide here is pretty typical of applications across all kinds of different markets where we get involved with networked lighting control systems. I would tell you, I seem to gravitate, seems most commonly to, that Class A type of office space where, maybe we're working on an office tower. Maybe there's multiple tenants in the tower with different requirements per tenant. We do quite a bit of that with networked systems. Hotels is another big one. And what we're seeing now more and more in that particular market segment, that vertical, is we're not just using the control system for the public spaces, but we're also being asked to control the guest rooms more frequently and then tie them into that network system. So if you're not seeing that, I would expect that you probably see that more and more going forward. But again, as I mentioned, we're not just limited to large commercial systems. We are seeing networked solutions for what were smaller spaces, Class B, offices, classrooms, so on and so forth. And some of those solutions may not, as I said, they may not have a processor that you necessarily can see or have installed as a separate component, right? It may be built into that load controller, and maybe that network is a Cat5 or a Cat6 connection to sensors and keypads. Maybe it is a DALI connection on a digital link, or it could even be wireless, right? These are the what I would call just some of the, if you will, fundamental building blocks for networked lighting control systems. The first one there is simply of course a dimmer on the wall that just in and of itself is typically not networked. However, there are wall box devices now, both wired and wireless, that you can interconnect to a network system, and certainly have them controlled, maybe from a system time clock, maybe report data back to the end user if that's what they're looking for. So it can give you very, very granular control. Kind of moving as we are from left to right, you'll see typically some type of a load control panel. This might be a relay cabinet, it might be a dimming cabinet. Oftentimes, I think, as you know, located in an electrical room where we simply run the lighting loads through those cabinets. It may be a feed-through design without breakers, or maybe it's got a lug set or a main breaker with circuit breakers, branch circuit breakers in them. Probably what I would call a little bit more of a traditional approach. What I see more and more, and primarily driving it, is, and I think everyone would probably agree or have experienced this, less and less room for us in the electrical rooms, right? So that kind of pushes us to that blue module there in the center, which is typically some type of a decentralized load controller. Typically, they are specific to the type of load that they would control. So you might have a DALI unit, you might have a DMX unit, you might have a 0 to 10 unit, 0 to 10 volt unit, so on and so forth. And oftentimes they are local to the space. So maybe they're up in the ceiling, or just outside in a corridor, but fairly local to the space that they're controlled, and then networked back to the local controls in that space or to a processor. And then, of course, we're seeing more and more wireless devices actually built in or supplied as part of the lighting fixtures, whether it's a digital fixture control that can be really almost hidden in the lighting fixture where you don't even see it, and that can communicate again back to the processor and provide the client with just a lot of different control options, but a lot of data that they may use to manage their facility. Sensors, I don't think this is probably too much of a surprise, but all of these systems, have different sensors, motion or occupancy sensors commonly referred to, daylight sensors, of course, both wired and wireless, high bay sensors, so on and so forth. And some of these can be intelligent in and of their own right and provide a lot of data, or others are really just kind of standard, if you will, analog sensors that tie back to those systems through some type of an interface or gateway on a wired or a wireless network. Wall controls, of course, there's a whole host of wall controls. These, of course, my recommendation is typically to try to keep things for the client as intuitive as possible. So I typically, when I sit down with a design team, will try to figure out, okay, well, what are we using this space for, and what type of a control design can we give them that they'll take advantage of, and they can use to maybe make some changes if they want to. But again, you don't have to have a technician in to show you how to change or adjust the lights if you need to do that. So lots of options with wall controls, both wired as well as wireless for these systems. Some things to consider as you're kind of putting together a design. The first, as I mentioned, I think would be, your intuitive controls. You want the controls to be, I think, fairly straightforward for the client so that they will use them and take advantage of the features of the system. I can't tell you how many times over the years I've been asked to go out, look at a system, and maybe it's 10, 15 years old, and there's been a generation or two of facility management people in place since that system was installed, and there's a 12, 13, 14 button keypad on the wall, and at one point they figured out that one button seems to turn the lights on and another one seems to turn the lights off, and that's all that they use. So we really try to help people, and come up with designs that for the keypads that look good, but also help them in the space such that they'll use the controls. Shades is another big one because sunlight has a real impact on the space. One of the things that I try to recommend people when they're looking at the lighting design or at the lighting control design is, hey, don't forget about the shades. They seem to come later in the project, sometimes unfortunately almost as an afterthought. So we try to bring that up fairly early, so we're at least thinking about them. And most of the manufacturers of motorized window shades today make a low voltage system. So sometimes showing a 120 volt power drop at the window where you think you want the shade motor may not be the best thing for the client when that project goes to bid, as a general rule, because it's less expensive to pull low voltage wire than it is to pull line voltage wire and the other components that are needed there. A couple of other things, dynamic light. Of course, a lot of these systems can do all kinds of things with the lighting. Things that come to mind, of course, would be certainly lighting scenes. That's been around for a long time, but now they can do daylight mimicking oftentimes, where depending on the fixtures that you've chosen, we can actually really track very well what the sunlight is doing outside of the space, so we can track the color temperature very accurately, and in an attempt to bring that sunlight more deeper into the space. What's really important about doing things like that, whether it's something like presets or it's something like, as I said, daylight mimicking, or even color tuning or different colors, is to really try to figure out ahead of time what the sequence of operation will be for the project so that it can be set up properly during commissioning. Of course, most of these systems now have apps. Just a quick couple of thoughts here. These apps are, as a general rule, very intuitive and very easy to use. But it is software, so we have to understand that if the client is comfortable with an app, is it something that they want, or do we want to maybe look at a system that may not require an app or may not require an app to function, right? And then because now we're in the world of software and some type of a connection, it's always very important to have the IT department involved early on as we're designing these systems. Of course, service is very important, right? We want to make sure that we can start these systems up, that we can support the client with questions that they may have, ideally locally as much as possible. So, making sure that you've got a team of people to support them, whether it's the initial startup or down the road. Of course, is something that we always want to make sure we look at very closely. And then there's other, as I mentioned before, there's other things that come into play. Do I need to tie into the mechanical system, the building management system? How do I do that? What I find it seems to be the most common approach is BACnet, and that's something that seems to come up now and now more frequently. So there's some things, as I said, to consider as you're putting together a design. This slide here may be a little bit intimidating, just because I think it's an attempt to show you all the parts and pieces that could potentially be on a network system. It doesn't mean that you would obviously have all of these. You can almost kind of pick and choose as you need them, but typically you're going to have a processor of sorts. Oftentimes that's determined by the size of the project and the processing capacity of that particular processor. As a general rule, I find you typically would have, if it's a tower or something, maybe one per floor. And then this kind of, I don't know if you can see it very well, but it's kind of a light blue line. This typically would represent what we would call a network drop. So the processor would have usually an Ethernet port or a network switch inside it, and that's where we take that Cat5 or that Cat6 cable to the building network, so that processor then is on the network if it needs to be, and it could be on a virtual network, allowing the customer to control the system from a server, or certainly it could be cloud. But this is what gives them the ability to do, certainly app-based control if they want to take advantage of that, as well as provide reporting, whether it's energy consumption reporting or it might be space utilization, and so on and so forth. This kind of this little green line here, this light green line, that typically would represent, a wired digital connection from the processor to the components. So on that link, for lack of a better term, you might have keypads, you might have your modular dimming or switching panels like you see here. You might have a central cabinet, or you might have any combination of the two, as well as then typically interfaces that you might need if you're tying into maybe for example, a contact closure interface there. If you're doing partitioning in a space, that's something that would live on that link, or an AV interface, potentially an interface for the shading systems as well. So that's kind of how a system architecture would go together. And I think any of the folks here on the call could be happy to help you put that together if you're working on a project. I think, just in the interest of time, I think I'm going to turn it over to Caitlin. All I just wanted to do quickly is just touch on, I know she's going to cover DMX 512, but here's a couple of lighting control loads that are pretty important that really you should consider. Phase dimming, which is typically two-wire dimming. There is a difference between forward phase and reverse phase. Reverse phase is oftentimes referred to as ELV, where forward phase is either TRIAC or MLV dimming. But that's very important to sort out, because they are two different signals. And again, we can go into that in a little more detail if you're very interested. I bring that up because sometimes they're used interchangeably, and they're really not. You may have a module like this just with a two-wire connection to the fixture or fixtures that it's controlling. And I think everyone's familiar with 0 to 10. Pretty very common now, of course, as a control technology. I'm not going to spend a lot of time on this, but as a general rule, as we reduce the voltage, we typically see, or increase the voltage, we typically see more or less light. But one thing that is important that sometimes contractors forget is this is really a four-wire connection, right? You've got your power, your hot, and your neutral to the fixture, and then your 0 to 10 volt control. So with that said, I think it's time to turn it over to Caitlin, who's going to talk to you, I believe, about DMX 512 and some of the applications there. Of course, I'll stick around if there's any questions going forward on what I just did. Caitlin, I'm going to turn it over to you.
All right, thank you so much, David. Appreciate it. Let me see if I have control, Sam. There we go. All right, well, thank you all so much for attending this today. My name is Caitlin, and I'm a lighting control specialist. I'm actually a theatrical lighting designer by trade and have a degree in theatrical lighting design, so I'm pretty familiar with DMX and complex lighting systems. Because I have a background in theater, I wrote myself a script for today. So if it sounds like I'm reading, I am. So DMX 512 is most commonly known as a control protocol used for stage and event lighting, which is certainly where it was primarily used in its early days. The protocol has grown over the years to be the backbone of large scalable systems controlling everything from lighting to rigging. DMX 512 has grown in popularity throughout the commercial architectural world as the most widely used protocol for color-changing luminaires. DMX has been adopted globally, which contributes to its interoperability across various manufacturers and devices. Common uses are for color-changing components on the exterior of a building, theme park, event center, intimate restaurants, or color tuning for circadian rhythm in schools and hospitals, and obviously theaters and performing arts centers. DMX 512, or more simply known as DMX, was created in the early 1990s by the United States Institute of Theater Technology and is currently maintained by the Entertainment Services and Technology Association. The 512 in the name DMX 512 refers to the number of individual addresses or channels within one universe of control. To put this in perspective, a white-only fixture occupies a single DMX channel, while an RGBW fixture utilizes 4 DMX channels, one for each parameter, such as red, green, blue, and white. In literature, the term channel is often interchangeable with a DMX address. The important thing to know is that it requires a single DMX footprint. For example, some luminaires require a single channel, which could be white intensity, single color intensity, or warm dim, where multi-channel fixtures could be tunable white with both warm white and cool white LEDs or RGBW. And in some cases with theatrical moving lights, we can get upwards of 48 channels. To break this down a little further, each channel has an 8-bit range of 0 to 255 steps, or 0 to 100%. This precision enables fine-tuned color control and dimming resolution. Individual DMX channels are programmed in a controller or button stations for various looks or effects. For example, the exterior of a building with RGBW fixtures may be programmed to be all pink for Breast Cancer Awareness Month, or yellow to showcase support for its local IES chapter. Each one of these would be an example of a DMX scene. In 2006, Remote Device Management, or RDM, was introduced. This revision allows for bidirectional communication and additional configuration elements. It enabled fixtures not only to receive commands, but also send feedback to the controller in between packets of data. This bidirectional capability opened doors for enhanced control, remote monitoring of status, diagnostic issues, and firmware without physically accessing the device. Oh wait, I jumped slides too. No, I didn't. Sorry, guys. It's a little confusing. There we go. DMX operates on a daisy chain topology, commonly utilizing a Belden 9729 cable with 2 twisted pairs and a shield. Alternatively, it can be transmitted over Cat5 Cat5e, or Cat6 cables, showcasing its adaptability to different infrastructures. There are a few basic elements of DMX we should be aware of. For starters, since it's a daisy chain topology, we cannot have loops, Y-splits, or junctions, and our total length needs to be kept under 1,000 feet, with a maximum of 32 devices per run. DMX is a serial protocol based on RS-485. It's basically a party line with one master controller which acts as the source and can send the signal down many devices that are listening. Beyond theaters, DMX finds its place in a myriad of architectural environments, from art galleries and museums to restaurants and dynamic indoor-outdoor spaces. The system architecture adapts to diverse space requirements and functionalities. In the gallery example on the top left, we see various devices. To start with, we have a show controller, which is the source of DMX, a mini panel, which is providing power and 0 to 10 volt dimming for general area lighting, while we have individual zone controllers that are feeding a 2-circuit track that's powering LED track lightings. The language of all these distributed devices are speaking DMX, which makes for an adaptable system. In the gymnatorium example on the bottom left, we have a small theatrical system which consists of one DMX station that a theatrical console is plugged into. This acts as the master when it's powered on. To the left of that, you have a DMX scene controller, which is generating one universe of DMX and allows for snapshots of individual DMX scenes on the button stations. To the right of that, we have another mini panel and then distributed dimming devices, all speaking DMX. In another example on the left, there is an integrated architectural system. At the center, we have the brain of our system, which is outputting DMX to a mini panel and dimmers for luxury suites. The brain is also communicating with a series of other DMX control panels, button stations, and specifically communicating with building lighting control system via network. A crucial component of the system architecture is emergency control. In such instances, bypassing the DMX signal becomes imperative to override the DMX and drive the DMX control fixtures to their correct emergency setting. This is commonly done via a UL924 DMX emergency bypass controller. When picking the right control solution, especially when we approach enhanced lit environments, we should take a few things into consideration. What are we lighting? Is it a restaurant with a few scenes, a museum with curated galleries and specific end user lighting requirements, a complex facade, or something else? How often will we need to change themes or colors, or do we need lighting effects or shows? What areas am I lighting? Small individual areas to large sports complexes? And what systems do I need to integrate with, such as AV or BAS? Your control needs will vary depending on your complexity and desired user interactions. As DMX is utilized in both large and small applications, the need for scalable lighting systems and multiple DMX universes necessitates the introduction of networks. DMX lighting networks introduce new devices such as DMX gateways and additional protocols. Two common forms of DMX networks are ArtNet and streaming ACN, which enable more robust architecture, added functionality, and programming flexibility. The top left image is a simplified scenario which includes a network box and 2 gateways to distribute DMX to 2 groups of fixtures. In the bottom image, we have a pretty complex system for a sports and entertainment complex. In this system, we have the lighting network as the backbone and multiple distributed control types. DMX is being used for the sports lighters, event lighting, specialty lighting in the suites and boxes, and DMX color changing fixtures in the retail spaces, which is driving the overall controls consideration. The image to the left shows a pretty extensive software setup for individual zones and user interfaces, which demonstrates the complexity of the systems. DMX is not only versatile and adaptable, but can transform spaces and experiences across the commercial, architectural, and entertainment landscapes. If there's additional questions about DMX, please feel free to put them in the chat or any other control topics that we're talking about. At this point, I'm going to pass it on to Sam, who's going to discuss DALI.
All right, good afternoon, everyone. As Caitlin said, just a reminder to put any questions in the chat. We are intentionally trying to wrap this up with a good bit of time left so that everyone has an opportunity to ask questions to the three of us. We will all three be hanging out afterwards, so keep that in mind and type those in. So moving forward, to talk a little bit about DALI. I'm sure it's something that a lot of you on the call are familiar with, but may not know some of the details or where it might be used. I know historically it's been largely used overseas in Europe. Just in researching for this presentation, I happened to notice the top 10 projects for DALI Lighting Controls Awards in 2022 were all in Saudi Arabia and in parts of Europe and other countries, and none of them happen to be in the US. But with DALI 2 coming onto the scene, the sequel to DALI, which is what we will focus on, there may be more opportunities to see this used on projects in the future. So DALI stands for Digital Addressable Lighting Interface, and it is a bidirectional digital communication between devices, meaning your drivers, your sensors, your switches, and any other peripherals that you may see. And it is intended to maximize flexibility in a space by giving you the ability to make changes to the configuration of lighting zones and occupancy zones, etc., without making any changes to the hardware. So DALI 2 versus DALI 1, there's an important distinguishment to be made there, that basically the DALI Alliance, with the original version, manufacturers would just register the device and say that it is DALI and meets the requirements that they listed. But with DALI 2, they have added a certification process similar to UL, for example, that allows them to verify and validate that the manufacturers applying for DALI 2 certification meet all of the requirements. So the DALI Alliance actually maintains this certification. So what that means is the control gear, which I will talk about in more detail on a later slide, has to go through a certification process, as well as all of the input devices such as sensors and switches. And they also have to validate backwards compatibility with DALI, and those results are published on the DALI Alliance website. As of now, any DALI version 1 is no longer registered or listed on the website. Everything must be DALI 2. So the DALI Alliance is a global organization for DALI lighting control. There are now more than 300 members worldwide in lighting manufacturing devices who have been certified by the DALI Alliance to use their logos on their products. So this includes hardware manufacturers, driver manufacturers, luminaire manufacturers. On the screen here is just a snapshot of some of the ones that have partnered with the DALI Alliance. So to give you an idea of the growth of DALI 2 from going back to 2016 up until the end of 2022, you can see here the blue columns represent the number of DALI products that are available. Then the value of that is on the right-hand side of the chart. And then the line graph in gray is, I'm sorry, I had that reversed. The number of members is the blue bars, and that is on the left-hand side. And then the number of DALI products available is the gray line, and that is on the right. So pretty steady growth since 2017, and some notable dates there is the DALI 2 LED driver requirement in August of 2017, and then adding input devices requirements about 2 years later. And I'll talk a little bit about D4I, which is kind of the further evolution, the next stage of that coming out in 2019 and into 2020. So DALI 2 components are comprised of control gear, such as, and primarily LED drivers. So these are what actually power the LEDs. There are DALI ballasts and other controllers for other light sources, but for the most part, we're going to see LED drivers in our market. And then there are application controllers, which are considered the brains of the DALI system connected to that DALI bus. So the application controllers will receive information on the DALI bus from drivers, from occupancy sensors, and any push buttons and other peripherals that are on that bus. And from that, it can essentially make if-then statements on how to manage that system. So it's an input-output device, as are all DALI 2 devices. That's part of the requirements. One of the important things to note here is you'll see in the middle of that image on the screen that each DALI subnet can only have 64 control gear devices. So consider that 64 luminaires with DALI drivers, and 64 control devices, your occupancy sensors, daylight sensors, and any push button interface devices, as well as the emergency lighting control gear. So some of the requirements, as I mentioned, the 64 control gear and 64 devices on a DALI subnet. And the DALI bus, which is a 2-wire cable, is carrying both power and data. So you do have to keep in mind that there is bus power requirements. One of the new features of DALI 2 is that the polarity of the wires does not matter. So that was a challenge that they had in the previous versions that had to be maintained by the contractor. The maximum length of this 2-wire cable is 300 meters. That's the cumulative length of cable between all of the devices in a single DALI subnet. And that's from basically the first device to the last device. Your cumulative total of wire cannot exceed 300 meters to maintain clean data communication and not have any interference. So on these DALI 2 systems, obviously you're going to need that bus power supply, which is going to enable the devices to operate. And this can be a standalone device that provides bus power or integrated into another device. For the most part, you're going to see the latter option there, whether that's the driver that provides the integrated bus power to keep the bus energized. And so that bus power is typically 16 volts and up to 250 milliamps of bus power will be on any given bus. So the advantages of DALI 2 are allowing for clear specifications by defining bus power requirements. This means that across the network of those 300 manufacturers that I alluded to before, that all of those devices, whether it's LED drivers or the hardware switches and occupancy sensors, the interoperability is greatly improved. By removing that polarity requirement, you have a simpler installation for the contractor that they don't have to manage that. And adding bus powered units which would be what I mentioned, the integral bus power, is less wiring by not having those devices that are required to add that bus power. The extended fade time is like a fade to off, and so it's very programmable to make those adjustments so that when you turn the lights off, you can have kind of a quick off or even a slow fade. These can be programmed based on time of day and things like that if you wanted to have a more architectural effect with the lighting controls. I mentioned the kind of next evolution of DALI 2, which is basically an additional requirement list that gives you a D4I certification. The vision of D4I is moving more towards your IoT applications. And the reason that it does that is because the requirements that it mandates a manufacturer to receive the D4I certification is the LED driver or the device that you're using has to be able to communicate specific data requirements. So for a driver, it has to communicate luminaire data, such as burn time and things like that. It has to communicate energy data, how many watts are being consumed, as well as the diagnostic data for maintenance and serviceability. And then for controls devices, one of the other things for D4I is you have to be able to manufacture luminaire embedded lighting controls. We have seen the rise of luminaire level control, and so DALI tends to address that with the D4I requirement, and also using that data that comes out of these systems to enable IoT platforms to do things like space utilization and asset tracking, etc. So in summary, DALI 2 expanded over DALI 1 by having a certified process for validating that a manufacturer's products meet the specifications for DALI and guarantee the interoperability between those devices. And D4I expands on that further for future proofing and allowing for communication, more specific communication with LED drivers and getting information from those for serviceability, for energy management, and things like that, as well as luminaire mounted control devices that are becoming more and more prevalent on projects. And then the DALI backwards compatibility, so you could expand on an existing DALI system with a new overlay of DALI 2 or DALI D4I. So with that, we'll move into Q&A. So keep in mind, you can ask questions directly to either of the presenters, David, Caitlin, or I. And of course, if you ask a general question, we'll just answer it accordingly.
Thank y'all so much. That was great information. We do have a couple questions in the chat. Are there any specific project types in the US that have been taking advantage of DALI? And is it recommended to be considered? It looks like John Chapman may have answered that as well, saying that it's a client preference. Either they know what they want or you need to give them the pros and cons so they can decide. But what can you guys elaborate on that, please?
Yeah, so when I was researching for this, one of the things that I observed is there's two sides of a DALI specification. There's the luminaire side, and then there's the peripheral side. And admittedly, I don't have a lot of personal experience with DALI specifications, so I want to candidly say that up front. And I know, David, you had alluded to some DALI components in our discussions about this presentation, so I certainly want to pass it off to you to give you the opportunity to speak. But what I saw is with a lot of luminaire manufacturers, I'm starting to see on spec sheets the option for DALI drivers. So that part seems to be a little bit more simplified, just like you're used to specifying fixtures today with different LED drivers, whether that's different dimming percentages, different brands of drivers, etc. DALI is becoming an option. But on the component side, there is a lot of manufacturers, and because of the interoperability of that, there's a lot to evaluate on components. A lot of switches that you could consider, and they have a lot of different aesthetics, a lot of different occupancy sensors, and different devices, etc. So parsing through all of that material is something that I was reviewing on the DALI website, and there's quite a lot there. So admittedly, we wanted to keep this presentation at a pretty high level. And so if a deeper dive into DALI specifically is something that you're interested in, certainly reach out to the local IES chapter, and that's something that we could potentially look at doing a full presentation on in the future. But like I said, David, if you have anything to add on DALI specifications and design, feel free to chime in.
Well, and thank you, Sam. I guess the only thing I would add that, in my opinion, is a pretty big deal with DALI is that new DALI, let's call it the version 2 or the 2.0. I think that is really going to help the adoption of DALI because it does require, essentially a third-party confirmation that a manufacturer is adhering to the DALI standards. So, I think that will help quite a bit going forward because it is really important, with an open protocol like that to make sure that everyone is essentially designing to a compatible standard, right? So that they can work, different systems can work together properly. So I think that's a pretty big deal that I think will help quite a bit. And then the other thing that comes to mind, there's a DALI version 2.6, which in the lighting world has to do with static color temperature, and then there's the version 8, which has to do with color tuning. Right? So something else to consider as you're specifying your projects, right? If you need color tuning, you want to look for DALI drivers as an example that might adhere to that 2.8 standard.
So Bob Henderson was asking a question in regards to DALI 2 for David and Sam. We have another one for you, Caitlin, so hold tight. Is the DALI 2 only for wired systems, or is it also available in wireless technology?
There is a wireless platform that is available for the DALI network. I did not get into that for this presentation.
Yeah.
It is somewhat of an open source platform that uses one of the examples I saw leverages the Zigbee wireless protocol, which is an open source protocol. So I believe it's going to basically rely on as you're assessing the hardware manufacturer. Again, like I mentioned, there's 300 members in that. Of the 300, I'm not sure exactly how many are making aux sensors or daylight sensors and other control devices for luminaires. So, but presumably a number of them are, and so they would have to offer the wireless capability for their products and advertise that as Zigbee. And there was a second protocol that I can't recall. But Zigbee is the one that I'm most familiar with and that other wireless systems on the market have used before, as well as residential systems like SmartThings and Philips Hue have been Zigbee based in the past.
Awesome. So Caitlin, can you control a fixture in a DMX system without a DMX driver? This is from Catherine.
Yeah, certainly. So you can control multiple load types within a DMX system. In the one gallery example, I believe we're showing 0 to 10 volt loads for general area lighting. So we can take those loads into like button station and touchscreen configuration and programming so that if you need to turn all your color changing fixtures off and 0 to 10 volt loads off at the same time, the same button press, you could certainly control them together.
Okay, thank you. So I posted this question because when we were getting ready to prepare for this meeting on lighting and controls, one of my most often questions for engineers is how do you determine or where do you draw the line for what is better for the client, independent controls or distributed controls? Like when is it that you decide, is it a financial thing? Is it a components thing? Is it both? So this is probably more for Sam and David. Caitlin, you can chime in too if you want.
David, I'm happy to jump in on that. So energy code can certainly be a driving force behind that as our energy code continues to evolve. It's not required in North Carolina to do daylight harvesting or plug load, but I've still seen a number of projects that adopt that. And when you add daylight harvesting, for example, it tends to immediately drive you towards a distributed approach. You need to have that digital communication capability to allow local dimmers to communicate with the fixtures as well as daylight harvesting devices. If you want to be able to have manual overrides and then have the space revert back to daylight harvesting, that tends to require a distributed system that has that capability. So energy code can certainly be one of the driving factors. Owner tech savviness, their willingness to take advantage of the flexibility that are offered by these systems. If they know that their space may adapt over time, or they have areas that fluctuate in application, then having digital lighting control systems gives them that flexibility. When these systems are installed, owner training is part of that. So theoretically, they should be comfortable in applying the softwares and apps that David alluded to. And so their willingness to manage those systems is certainly another deciding factor. And budget is always going to be a part of that as well. So that's something that local reps that you're working with can help you assess kind of the cost of individual versus distributed or standalone versus distributed, and kind of assess if that value is worth the additional upfront cost to the owner. And of course, discussing the management of that system, things like service plans can be helpful as well. David, anything to add?
No, the only thing I would almost add to that, I guess, is, I'm not sure there's necessarily a right or a wrong answer. And the reason I say that is, so many of these systems now, we have the ability because, at some level, they all are networked, right? You know, really, we can put them together almost any way you need us to. So it's really important to understand, okay, what is your client, what do they need or what do they think they need, right? What does it look like if they have future plans for their facility? There is a little bit that goes into it. But the reality is a lot of these systems now, we can put them together so many different ways, and they all work, I think, as a general rule, pretty well. So it's really just trying to understand and getting your head around, okay, what is the best fit for my client going forward? And of course, we do have to look at energy codes. I think most of these systems, as a general rule, by default, will meet energy code in most places. So yeah, it's really understanding what your client needs, what they want, and what you think they might want going forward, so that you can help design it to grow with them as they grow.
Thank you. So we're getting close to the end. I don't see any other questions in the chat. So I would like to see if anybody has any closing thoughts that they may want to add. We'll start with Caitlin.
No, I just want to thank everybody who attended today. I want to thank the other presentations, the other presenters, and IES for this topic. I think it's an important topic that we all discuss. Sam and David, you guys are very intelligent and spoke on your subjects very well. So thank you guys. I think this was great. I'd love to see the IES maybe expand on some of these topics too in the future.
Agreed. Gentlemen, anything you would like to add?
Just following on Caitlin's point of doing future presentations like this. I know the local IES chapter has been working hard to provide valuable presentations for this market. So this one had a pretty good turnout, which we're excited about. And thank you for taking the time to do so. So we are open to feedback and suggestions. If there's topics that you are interested in, please do reach out to any of us. And we'd love to try to find industry experts outside of this market as well, who are able to offer their time and expertise to educate this market more on topics and details. So please do provide feedback. That's very appreciative to us and allows us to do a better job serving you. So, and thank you again for your time.
So I appreciate all three of you expounding upon controls. It's always a learning curve for me to develop that thought process. I'm really into luminaires and lighting, and controls is a little bit more difficult for me. And that's the question that I get asked most by owners, engineers, and architects is about controls. So typically once a year, the IES does at least one of the educational trainings on controls. And we will be posting this on the IES YouTube channel. So if somebody has a new person in their company, they can go back and review it in the future. And with that, you guys have a great day. Thank you so much, and we appreciate the IES. Get in touch if anybody wants to increase their membership or renew it. It will be awesome. We appreciate you. Thanks, guys.
Thank you.
Thank you.